Today we're going to talk about how to use SPSS to run independent simple t-tests. SPSS is a very useful tool. It takes care of the calculation process for many statistical procedures by providing drop-down menus, pop-up windows, and point-and-click options. It's very user-friendly, and many students wonder why we still have to learn how to calculate statistical formula by hand. It is a good question that deserves a good answer. Let's go through an example using SPSS to run an independent simple t-test. Then we will go back to that question. However, before we start SPSS, let's do a quick review of what you learned for running independent simple t-tests. The 5-step hypothesis test for independent simple t-tests. In step number 1, you need to do a test for the equality of variance, and that determines which set of formula to use for the t-test. Step number 2, you need to state the hypothesis regarding the population means, mu1 equal mu2 or mu1 not equal mu2. And in step number 3, you have to identify the rejection zone for the test. And of course, step number 4 is calculate the t statistics. The t formula is x bar 1 minus x bar 2 divided by estimate the standard error of the mean differences in these two groups. Okay, on step number 5, make a correct conclusion based on your calculated t compared to your rejection zone and figure out what is going on from there. Look at how SPSS can help you. In this data set, it was the data set I collected when I was teaching 2 different sections of stats, and I have students measure a bunch of their personal measures, height, weight, head circumference, and they report their sex, male, female. It was coded as 1 and 2. Click on the variable view, click on the value label. Right here you can see clearly 1 is female, 2 is male. Okay, go back to the original data. Click on Analyze, and our purpose is compare group means. So compare means, and we know male, female are different individuals, so they are independent simple t-tests. SPSS asks you to put in the test variable. As we say earlier, we are interested in the height, and also ask you want to define your group. And as we talk about male, female, and right now SPSS asks you to define groups. So click on the define group button. The variable is coded as 1 and 2. So that's all you need to put there. Click continue, click OK. So voila, SPSS automatically generate group statistics, shows you group size, mean, standard deviation, standard error of the mean. And the next one shows you independent simple t-test. Remember our step number 1, we have to do equality of variance test. SPSS does the same thing. It's a reported 11th test of equality of variance. It's a F test. Significance, sig here is actually the calculated p-value. It's the probability associated with that particular F value. So it introduced a new way of judging whether your particular statistical test is significant or not. As we learned in the previous process, we use the rejection zone, the critical value of the test, to set up the boundary of the rejection zone to judge whether a test is significant or not. In SPSS, it actually it calculates the p-value associated with that particular test, and that makes judging the significance of a test much, much easier, because for any kind of statistical procedure, the software always provides you with calculated p-value associated with that test statistics. And the decision rules are all consistent. When the p-value, the calculated p-value, is less than the alpha level you predetermined. As we say before, a lot of time alpha is default at 0.05. So when the calculated p-value is less than the alpha level, we reject the HO. When the calculated p-value is greater or equal alpha, we fail to reject the HO. So that is a new decision rules we are going to be using when you look at the output of SPSS. Just for the ease of highlighting the outcome, I basically copy the output into a Word document. So it's the same number, exactly the same thing. Let's focus on the calculated F value for the Levin's test of equality of variance and the calculated p-value 0.770. The p is greater than 0.05, what we usually use. 0.770 is definitely greater than 0.05, so we fail to reject the HO. When you fail to reject the HO in the process of doing equality of variance, equal variance assumed. So when equal variance assumed, let me highlight this. That's because the calculated F has a large p-value. It's greater than 0.05. And as you can see, the SPSS report both equal variance assumed outcome in the first row, and also in the second row, equal variance not assumed. You see slightly different number there. Okay, so the calculated T when equal variance not assumed is slightly different than the calculated T for equal variance assumed. It's because you have different set of formula goes into the calculation. Okay, so when both set of the outcome are automatically generated by SPSS, as a user, you will need to figure out which row is the correct information. And as we say, based on the equality of variance outcome, the calculated P associated with this F is 0.770, and it is greater than 0.05. We fail to reject the HO. Therefore, equal variance assumed. So I'm going to highlight the correct row of the result. So the calculated T for the height comparison between male and female is negative 5.831 with a degree of freedom 67. And the significance of this T in terms of group mean comparison is highly significant. It's 0.000. 0.000, again, it's a calculated p-value associated with a test statistic. When the calculated p-value is 0.000, it's less than 0.05. We reject the HO. This outcome actually inform us there are significant differences between men and women on their height measurement. And the last column here actually tells you that 95% confidence interval of the group mean differences. The lower limit for the interval is negative 7.80, and the upper limit of the confidence interval is negative 3.82. So in this particular case, 0 is not included in the confidence interval. So this is another indication that there are significant differences between male and female's height.